In this video, we're going to take a look at Lesson 8, Practice Problems. We are going to skip number 1 and move on to question number 2, where you're going to have to find the area of the triangles. There's 2 different triangles here. It says explain or show your reasoning, so you could use words or you could show your work. In this first one, I'm going to just remind you of what we learned in the very beginning of our unit, that when we have a rectangle and we divide and we kind of slice that rectangle in half, we get 2 triangles. So this is how we know that the formula for a triangle is half of the length times the width, or base times height. So if we know we have a rectangle and we know the rectangle formula is base times height, or length times width, remember it's the same thing, then to find, this is for the rectangle or parallelogram, and if we cut that in half, we get a triangle. So we can do the triangle. I forgot the N. We get a triangle. So when we're trying to find the area of a triangle, we can do base times height and we can divide by 2 because it's half. So I can see the base here is 1, 2, 3, 4, 5, 6. So my base is 6. And my height, now the height is very easy to see right here. Do you see that right angle? There's that T that we talked about, perpendicular. And there's 1, 2, 3, 4 going up the side there. Okay. And again, I can find that height here. I can find that height here. I can find that height here. I can use any of these line segments to find the height as long as I'm going from this point, this line. And again, I love using that marker because you can see the invisible line. It's almost like this invisible line up here, like the ceiling, and you're measuring from the ceiling to the floor, right? Okay, so 6 times 4 is 24, but we don't want that. That would be as if it were a rectangle. That's the area of this whole entire yellow space if we wanted to include both. We've got to divide by 2 because we're looking at half. It's half of the rectangle. So my area would be 12 units squared. And you can write units squared or square units, however you like to do it. All right, now this next one is a little bit more challenging because if you were to connect this, if you were to fill in that missing space, what this is actually is a parallelogram. And I can show you by creating the parallelogram. So look at the base, and do you see the base has 1, 2, 3, 4? So my parallelogram would have 1, 2, 3, 4 at the top, and then these 2 points would connect. Okay, so you can see the invisible parallelogram, right? Okay, so again, just like the rectangle, if I take a parallelogram and I slice it in half diagonally, I create a triangle. So again, I know the formula for a parallelogram is base times height, right? Which is what we've been learning. The triangle, it's so much easier because we know that half of the parallelogram is a triangle, half of the rectangle is a triangle, then we just divide by 2. So half would equal the triangle. So we just have to divide by 2. All right, so we can see our base. It's 1, 2, 3, 4. So there's the base, 4. And then our height. Remember, the height is going to connect the floor to the ceiling. The floor to the ceiling. So how many units is it from the floor to the ceiling? Well, we can use any one of these line segments going up to the ceiling, right? So I'm going to use this one right here because I feel like using this one. 1, here's 1, 2, 3. See that? So there is that perpendicular top and bottom. We can make that perpendicular at the top and bottom. I have my height. My height is 3. 3 times 4 is 12, but we don't want to stop there. 3 times 4 would be the area of the parallelogram. If it were a parallelogram, which it's half of a parallelogram because it's a triangle. So I'm just going to divide by 2, and I can see that I have 6 units squared. Okay? So remember, when you're working with triangles, triangles are half of squares, rectangles, rhombi, parallelograms, okay? And all we have to do is do the standard base times height and divide by 2 to find half. All right, let's take a look at this. Which of these three triangles have the greatest area? Show or explain your reasoning. If you get stuck, try using what you know about the area of parallelograms, which is true. I agree with that. Okay, so I'm going to go ahead with A because A is the easiest. A, if you, again, I love connecting it. If I connect, I can see the rectangle. See that? Okay, so my base is right here. It's so obvious. Sometimes it's really obvious to see the base, and then the height is right here. So for this one, I don't have to do any imagining of lines, right? I have my base, my height. So I have 1, 2, 3, 4, 5. So this would be a base of 5, a height of 1, 2, 3, 4. And again, I don't want to do 4 times 5 is 20. The answer is not 20. That would be 20 if it were the whole rectangle. It's 4 times 5, base times height, or height times base, whichever one you want to do first. And then I'm going to divide by 2 because it's half. 10 square units. And I'm going to write it a little differently this time so you can see that it doesn't matter if you write units squared or square units. Okay, now this one is really tricky. I'm not going to lie. This one is actually a rhombus. If I were, or a parallelogram, if I were to take this triangle and were to reflect it like this over its side, it's actually going to create a rhombus or parallelogram. I'm going to show you what it would look like. I'm going to draw the line, the yellow kind of highlight. So this is actually the base. 1, 2, 3, 4. This is the base. Again, I'd have to turn my paper around to really see it. Same with this one. This one's a base as well. This is a base. These are on their side. So if this is the base, that means this side has to also have 1, 2, 3, 4 units. 1, 2, 3, 4. And then I'm going to connect these two dots right here. Okay, so now you can see the parallelogram. And it's, again, like I said, it's on its side, so the base is kind of harder to see. The base almost looks like the height, right? Okay, so 1, 2, 3, 4. So we know that that is 4 units. Now, where is the height? Remember, the height is going to tell me how far apart these line segments are, the straight line segments. How far apart are they? Well, we can look at it across the bottom, and again, I'm going to draw that. I'm going to extend it so you can see this imaginary line kind of goes on forever. If I go across 1, 2, 3, 4, 5, there's the height. I can also go straight up the middle. 1, 2, 3, 4, 5. See that? Okay, I could even do the top. 1, 2, 3, 4, 5. Okay, so we know now that our area is, I'm going to write it up here, 4 times 5, but remember 4 times 5 would be if it were the parallelogram. Okay, we're going to divide by 2, which is 10. 10 square units. Now, check that out. A and B have the same area. They have the same area. Okay, they look different, but they have the same area. All right, our last one. Here we go. The last one is very similar to this one. We see the base is right here. Okay, it looks like the height, but it's actually the base. And again, if we rotate it around, we can see there it is. Okay, now the height is kind of weird because it's kind of crooked, right? So let's recreate the parallelogram. 1, 2, 3, 4. So we know that base is 4. So this side also has to have 4. 1, 2, 3, 4. And then we're going to connect these two. Okay, see that? There it is. All right, so we know the base is 1, 2, 3, 4. And what's our height? So again, our height can go from the top to the bottom, or in this case, left to right, because it's on its side, it's rotated. So let's just go here. Let's go from this point to this point right up top here, because see how it matches? It's the same height. All right, 1, 2, 3, 4, 5. Oh my goodness, guys, look, it is exactly the same. These all three have the same area. 4 times 5 is 20. But because it's half, we're looking at, because it's a triangle, we're dividing by 2. So this would be 10 square units. Okay? Pretty cool stuff, right? All right, that was practice problems 2 and 3 for lesson number 8.